Okay, in this presentation we're going to look at a probability exercise. So this is a part of the introduction to probability series of videos. Okay, so straightforward enough exercise and we should get through it fairly quickly. So if there are two events A and B and they have the following probabilities: probability of A equals 0.3 and the probability of B equals 0.6, and we're given the further information that the probability of A given B is 0.2. Okay, so this is a conditional probability, which is very important because it gives us further information that we can use. So, three questions. Are A and B independent? Justify your answer. Are A and B mutually exclusive? Justify your answer. And then finally, calculate A union B. Okay, so that symbol there between A and B is the union symbol, which essentially A or B. Okay, so just to recap on what we've been given: probability of A is 0.3, probability of B is 0.6, and probability of A given B is 0.2. So, are A and B independent? Justify your answers. Okay, so two events A and B are independent if probability of A intersection B, okay, or A and B equals probability of A times the probability of B. Okay, so we're going to use the conditional probability value there, this expression here, probability of A given B, and essentially what we could do is use it. You use the idea of conditional probability to figure out what probability of A and B is. Okay, so just rearranging the expression for conditional probability, we have probability of A and B equals probability of A given B times the probability of B. And that is 0.2 times 0.6, which is 0.12. So now we're going to calculate the probability of A times B. Okay, A times B is 0.3 times 0.6, which is 0.18. So the probability of A and B is not equal to the probability of A times B, so the events A and B are not independent. Okay, so moving on to the next one. Are A and B mutually exclusive? Justify your answer. So we have two events A and B, and they're mutually exclusive if probability of A intersection B, probability of A and B is 0. But we already know from the previous exercise that that is not the case. From the previous exercise, we found that probability of A and B, A intersection B, equals 0.12. I'm verbalizing that both ways. One or the other is fine, actually. It's just I'm verbalizing it both ways, just in case you hear one or the other. But really, they mean the same thing. The intersection is really just the intersection symbol. Anyway, going back to the question, since A intersection B is not equal to 0, the events A and B are not mutually exclusive. And finally, calculate A union B. So using the formula for the union of two events, that is, probability of A union B, or A or B, is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay, so that is A union B equals 0.3 plus 0.6 minus 0.12. And a little bit of calculator work, and that works out to be 0.78. So probability of A union B is 0.78. Okay, we'll leave it there.